In this tutorial, we're going to do a comparison of covalent substances and ionic substances. And for our example of a typical covalent substance, we're going to take octane, which is present in petrol, and our example of an ionic substance, we're going to take sodium chloride, which is more commonly known as salt. So if we look at one thing at a time, the first thing we look at is what is it that goes into making up these substances. And we see that covalent substances are made only of non-metals, whereas ionic substances contain both metals and non-metals. And we'll use our Venn diagram to record the similarities and differences. So as we said, one major difference is covalent is made of non-metals, whereas ionic are made of metals and non-metals together. But we could put in as a similarity that they both do contain non-metals. So if we flip back and then look at something different, the type of structure that they make, we see that covalent tend to form simple molecular structures, whereas giant ionic compounds form these giant ionic structures. Like we have here in sodium chloride, this could just keep building up on and on and on in the same pattern, whereas for octane, this is it, finished. That's what the molecule looks like, doesn't extend anymore. So putting these into a Venn diagram, we see that covalent forms simple molecular structures, whereas ionic substances form a giant structure of ions. Looking at the next thing on our list, if we look at melting points and boiling points, we see that for octane we have minus 56.6 where it melts, turns from a solid to liquid, and 126.1 degrees C where it turns from a liquid to a gas. Whereas with sodium chloride, if we want to melt it, we have to heat it up to 808 degrees C, and if we want to then boil it, turn it from a liquid to gas, we have to go really high, 1465 degrees C. So if we record this major difference, we see that covalent substances have low melting points and boiling points, whereas ionic substances have very high melting points and boiling points. Looking at something else on our list, if we're looking at whether these are elements or compounds, we see that octane is a compound and sodium chloride is definitely a compound. So this is one thing that they have in common. We can have covalent compounds and we have ionic compounds. So this goes in the similarities in the middle. And again, just to show one thing that we pointed out earlier, carbon and hydrogen are both non-metals. Chlorine is a non-metal, but here we have a difference where the ionic compounds also contain a metal. However, it's completely straightforward as that. If you look at the previous tutorial with covalent substances, we can see that things like hydrogen and oxygen and nitrogen and chlorine are also covalent substances. These bonds by sharing electrons, and all of the atoms in each of these substances are the same as each other. So these are all elements. This gives us an important difference in that with covalent substances they can also be elements, whereas with ionic substances those are compounds only, because they must, by their definition, contain a metal and a non-metal element, two different elements. If we think about substances other than octane and sodium chloride, if we think about some of these ones, the elements we talked about, we see that these are gases. Octane itself is a liquid. And if we also think of something like iodine or sulfur, we can see that covalent substances can exist in, or do exist in, all three states under normal conditions. Ionic substances, however, because of their high boiling points and melting points, exist as solids only. And the fact that they do exist as solids, as well as some covalent solids, is also a similarity. And one last thing that we should put in is how they bond. If you remember, covalent substances bond by sharing electrons, whereas ionic substances bond by transfer of electrons from the metal to the non-metal. So, in summary, there are some areas where we can see similarities between covalent and ionic substances, but mostly in these sections here we're recording where they're different. So there we have a quick, simple comparison of covalent substances, ionic substances.